Hello, this is Donnie Smith, and in this video we're going to talk about vehicle design, how the vehicle is made from the automakers and some of the changes through the years. Now we're not going to get real involved in vehicle design, just a brief overview so you kind of understand the concept of it. And whenever you go to uh, repairing frames, that's going to become a lot more important. But for now, we're just going to kind of give an overview so that you understand the basics of vehicle design. Now, if you think about it, we've came a long ways in the past 100 years. If you think back when Henry Ford started mass producing the Model A's and Model T's, quite a bit of difference in those cars and the cars of today. Those cars is basically built with ladder frames, and what that means is just basically two rails. If you think of a ladder, it's two rails with cross members, and the way it had it for strength, is just by, it was thick metal and it was real heavy duty, real thick gauge steel to get its strength. And the problem with that is, if you think of two rails, and whenever it would, have an accident, whenever it'd run into something, have a wreck, nothing would give. That frame was real strong and stout, and it'd hit something, and the passengers would take all the impact themselves. It'd be like being bolted onto a railroad, you know, track, a part of one, and slamming up against a wall. You think of how much impact your body would take. Um, like they say about falling, it's not the fall that hurts you, it's that sudden stop. And this is the same thing, that was causing a lot of accidents or a lot of injuries and deaths due to that. So they started trying to make cars safer, and at the same time the government wanted to make cars that was better fuel efficient. So they started coming up with ways to make cars lighter, and they started engineering at the same time lighter and safer. And the way they did this is to make weaker areas in parts of the car. And this is called crush zones, collapse zones, and this was absorbed some of that energy, kind of acting like a shock absorber. And they'd also make stronger areas to help protect the passengers, and that would transfer the energy around the passengers to keep them safer. Now I'm going to pause just for a second, or have you pause for a second, and kind of explain why you may need to know this, because you may be asking, why do I need to know this? If you're going to be a painter as a profession, or you just wanting to, fix a few minor dents and, do it yourself, this may not be, that important to you. But if you're going to be an estimator or a collision repair technician, this information is really important, because you need to know how a car is designed in order to develop a repair plan. If you don't really understand the concept, it's going to be hard to, get it all in your mind of what happened in an accident and try to reverse that damage, because you've got to, reverse whatever happened in the accident, the first in, last out. And we mentioned crush zones. You need to understand those and know where they're located, because if you're going to section something, you never want to section in a crush zone, and that's something you need to know. And we'll talk about here in a minute some of the newer cars even have areas that have crush zones, but you can't see them. So it becomes that more important to understand how vehicles are being made. So let's go ahead and continue. We're going to talk about crush zones a little more. And like I said, this is like a shock absorber. It takes part of the energy. You can think of it like putting a huge shock absorber in the front of the car and letting that slow the car down before that sudden stop. That's what cars are designed to do. And I know you hear, they don't make them like they used to. Meaning, I had a car and I had a little accident and it just totally wiped my car out. And that's true. Cars do take a lot more, or there's a lot more damage in an accident than the older cars. But people are actually coming out of these accidents, with a lot less injuries. So cars are safer today, even though the cars are, have a lot of damage when they are involved in an accident. But if you think about it, we want to keep passengers safe. If it was you or your family in that car, I'm sure you could care less about the car. You want, yourself or your family members to be safe. So that's what where car designers are putting all these, crush zones and stronger metals, around the passenger compartment to try to design this where it does keep you safe. So you've got the front and rear section, that's designed to absorb the energy, take some of that impact. And then your passenger compartment, that's where you have some of those stronger steels that we're going to talk about, and it's designed to protect the passengers. Now you got vehicle sections, and this is also important to know, and it may be sound very simple, but there is some confusion. For example, there's a right and left, and you'll need to know this whenever you're doing frame damage work or ordering parts. Is it from facing the car, or which one's right and which one's left? Well, the way to remember this is if you're driving down the road, you're sitting in the car facing forward, your right hand is always the right side and your left is always the left side. So if you're ordering a right front fender, that's going to be the passenger fender. Uh, and of course the passenger or the driver is going to be your left fender. Also have sections. You have the front section, which is basically from the windshield forward. You have the center section, which is the passenger compartment from windshield to back glass. And then you have the rear section. That's your trunk area. That's your three sections. And we're going to talk about some of the parts in each one of these sections. It's also important to understand the names of the parts, the nomenclature, so that you know if you're ordering parts or you're repairing a part, reading a repair order, to kind of have an idea of what these parts, the names of them. So you've got in the front, of course you got the bolt-on things. You have the front bumper cover, grille, headlamps, and you've got the radiator support. And the radiator support's actually part of your unibody. Now, whenever I talk about unibody, that's just the design. I've heard people say that unibodies don't have frames. Well, they do have frame rails, but what unibody means is uni means one, so it just means everything, including the frame rails, are welded together to make one piece, rather than the body over frame, which the body bolts to the frame. So on a unibody, you get the radiator support, which consists of several pieces, and you get the upper tie bar and the lower support, where the headlights bolt in. All that's part of your radiator support. And then you've got your frame rails. You got upper frame rails and you got lower frame rails, and each one of these parts can be replaced or sectioned. You take that part out, drill the spot welds, or section it, in a certain area. And like I mentioned, you need to understand crush zones because you don't want to section in those areas. Also have the fender aprons, and that's what the fender bolts onto. So you're going to have a right apron and a left apron. The strut towers, that's where your struts bolt into, and that's on the apron. And of course, your bolt-on parts are the bumper, grille, headlamps, fender, and hood. That basically, consists of your front part. And again, the front area of your car is designed to absorb, and that's done with crush zones. Now we've got the center section, and this is your A pillar or windshield pillar, your B and C pillars, and basically, like I said, it's from the windshield to back glass. That is your passenger compartment. Also consists of the rocker panels, that's below the doors, the floor pan and the roof supports, and then you've got your roof panel, your doors, and your glass. That is basically all of your center section. And this part is designed to be really strong. You don't want it to absorb energy. You want the passenger compartment to transfer all of that energy, all that damage around you, around the passengers. Now we have our rear section, and again we've got our rear frame rails, the trunk floor pan, the quarter panels, the rear body panel. That's what your tail lights bolt onto. And then you've got your bolt-on panels like your deck lid and your tail lights and rear bumper cover and bumper reinforcement, and all those that attach to the rear section. And again, the rear section, it's designed, if you get hit from the rear, to absorb some of that energy, so you don't have that real so the passenger don't take all that impact. So the front and rear absorb energy, and the passenger compartment transfers energy. Now we're going to talk about a few of the different frames. We've kind of been talking about unibody, but there's actually three basic types of frames. and that's full frame, unibody, and space frame. So let's talk about each one of these a little bit. Now, full frame, that's just a regular frame like the ladder frame we was talking about, but even those now have crush zones designed in them where they will absorb energy as well. But what a full frame is where it's two pieces. You've got the frame and then you got the body that bolts onto the frame. It's two pieces. Now, there are some unitized bodies that's one piece that bolt onto the frame, so it's like having a unitized body that is one piece that bolts to the frame. On a full frame, the suspension, the engine, transmission, everything bolts to the frame. So you could take the body off, or all the body panels, and all your mechanical parts would still be bolted onto the full frame. Now, unibody, that's where all the structure is. It's one piece. So you've got, like I said, you got all the the frame rails, the floor pan, all that is welded into one piece, and they're usually welded together from the factory. Different methods. Probably the most common is spot welds, and that's where the machines go in and they squeeze the metal together, and there's no filler metal added. It just squeezes it together real tight, heats it up, and fuses the metal together. So you'll just see round dimples where this happened at, and that's a spot weld. And then you have space frames. Now, space frames a type of unibody, but the difference between a space frame and a unibody is a space frame has its full integrity in the frame itself. For example, with a unibody, it takes some of those panels that's welded on, like the quarter panels and the roof and all that, to kind of weld together to get its full strength. Well, space frame, you could take all the panels off of it and it'd still have its full integrity. If you think like a funny car, race car, and the bodies on there are just for looks. Maybe some aerodynamics, but it's mainly just for looks. You could take the body off, and that car would still be just as strong. The tube frame. Well, that's kind of what a space frame is. So a space frame is a type of unibody, but a unibody is not a space frame. So how are these cars held together? Now, we mentioned a spot weld, and that's the majority of the welds, but there's also some laser welds, which are done by machine. Um, Mechanical, there's some mechanical ways cars are held together, and this can be with nuts, bolts, rivets. And also there's a lot of adhesives being used. There's some benefits to adhesives because it helps seal out the moisture. And that's something else with these unibodies, is you got to consider rust. So if everything depends on its these panels for its full integrity, rust is more than an eyesore. You see a rust spot on unibody parts, and it actually is weakening the structure of that car. So these adhesives help seal out moisture to prevent these vehicles from rusting. Now let's talk about some of the materials used, because this is where there's a lot of changes in the steels. Uh, the earlier cars was all mild steel, and to get that strength you basically had to use thicker steel. But they started using lighter steel and putting different alloys in it and making high strength steel. So what excuse me, what this would be thinner metal, but it still have the hardness of a thicker steel. And then they also start developing ultra high strength steels and borons, and this is even harder steel. And this is done with alloys and by heating it up, different type of heat treatments, and making this metal really hard. And of course, this is your real strong steel, and they're going to use this around the passenger compartment. They're going to use it, inside of the doors, in the intrusion beam and areas like that, to keep the passengers safe. And also, the government is still wanting better fuel mileage, so I think you're going to see a lot more plastics. I mean, there's already a lot of plastics in SMC, or SMC, which is sheet molded compound. Uh, Basically, that is just it's a fiberglass, fiber reinforced plastic. Um, but you're going to see a lot more of those because they are a lot more lightweight than some of the metals. and carbon fiber. There's some of that out there already, but I think we're going to see a lot more of that because it's super strong and really lightweight. So if the car makers are going to have to make cars that get a certain miles per gallon, they're going to do whatever it takes so that they can sell these cars. And it really doesn't matter the cost of the materials because they have to make them to get the certain miles per gallon. So it's just going to, if there's higher materials in it, the car of course is going to be more expensive to purchase. So I think we're going to see a lot more lightweight materials in the plastics and the composites as we move forward. Now when we start talking about these repairs to like ultra high strength steel and boron, there's a lot of considerations that didn't used to be there. It's very heat sensitive. You can't hardly heat it. A lot of manufacturers recommend no heat at all because if you heat it up, it loses those properties from the heat treatment, and basically you're getting something that was supposed to be boron or ultra high strength steel, and you're changing the properties of it, and it's not that, it's not the have the strength that it's supposed to. So it's involved in an accident. There's going to be unnecessary injuries. You can't really repair it. You can't really repair those type of steels because it's so hard. If you go try to straighten it, it's probably going to crack. So most of your ultra high strength steels and boron are replace only. So like in the intrusion beams in the car and anywhere that's indicated that it's ultra high strength steel or boron, not going to be much repairing. It's going to be replace. Another thing that vehicle makers started doing to be able to get the cars stronger, the metal stronger with lighter weight or with lighter steel, is to put more body lines and curves in them. If you take a regular even mild steel and you bend it like a body line, it strengthens that steel because it work hardens that steel in that area. Now this is another consideration because if there's some damage in a body line, it's going to be harder to repair there than it is just a flat area. So whenever you're looking at a car and you're estimating it, or you're thinking about a repair plan whenever you go to repairing it, that's going to make a difference where the damage is at. Basically, there's some common types of frame damage. You've got sag, and this is very easy to indicate because sag is usually in the cowl area. That's right at the front door and the rear of the front of the front door and the rear of the front fender. Easy way to see that is by your gap there. If it's real narrow at the top and wider at the bottom, that's a good indication that it has sag. And there's side sway, and that's where the front end doesn't have to be the front end or back end's pushed over one way or the other. And a good indication of this is the gaps wide on one side of the gaps and narrow on the other. That's a good indication of side sway. And then you have mash, and this may be a little bit harder to determine just by gaps, but that's basically where the frame has been shortened, from what the specification should be. And then you have diamond. Now this can happen to unibody, but it's more normal, more common in body over frame. This is where it actually gets your frame and it kind of gets it out of square, from pushing it back so far. So, and there's one more which is not very common on unibody, or if it is, it's probably going to be totaled, which is twist. That's where it just basically twists. So when we do get some frame damage, we got to think about how to measure this damage. First off, I'm going to talk about control points. What are control points, reference points? Well, control points is where the factory put these pieces together. The robots have to grab these pieces in certain areas and they hang for in jigs, putting it together. Those points where these machines grab are designed into there just so that it for the jigs that it's fitting into. So that's control points. Now reference points is what you're going to use when you go to measuring the damage. Now it could be a control point that was from the factory, like a hole, but it could also be a bolt or just anything that they reference as a point. So whenever you look at the specifications, it's going to give you references. From this bolt to that bolt should be, you know, 33 millimeters or whatever. So that's what a reference point is. And then there's tolerance, and what that's talking about is how close can you get that car back to within tolerance. So if it says 133 millimeters, kind of the general rule of thumb for a long time was 3. If you can get it within 3 millimeters, so if it was 133 and you got it to 130, that would be good. But the cars being designed today have less and less tolerance, and there are some that they really don't give any tolerance. And if it's off just a little bit, the body panels are not going to line up, and you're going to see uneven gaps. In the body over frame in the older vehicles, you could adjust the panels to, where it could make the, you could make the gaps line up. But if you're not dead on with these cars, with these newer unibodies, it's going to be very noticeable. Now let's talk about also, we talked about, the first in, last out. You want to reverse what happened. So there's some predictable things, but it's not an absolute. But a lot of times if you're driving and you see you're going to hit, head on with another car or whatever it is, there's some common things that a driver's probably going to do. And the first thing they're probably going to do is hit the brakes. Well, when they hit the brakes, the front of the car goes down and the rear of the car goes up. You got to think of the inertia that's going on. So when it hits, it's got that momentum of the front going down and the back going up, and that's why you're going to get the sag. And that's the first type of damage that usually happens, is that sag. The second thing that you're probably going to do, just out of natural reaction, is you're going to swerve one way or the other. So you're probably not going to hit them straight on. So you're probably going to swerve the wheel just a little bit, and by doing this, it's going to cause the front end to go one way or the other, and that's going to give you side sway. And as the collision continues, the momentum continues to collapse. It's going to cause the unibody to mash, which is going to shorten the frame, wherever the point of impact is. And then, of course, if it's hit hard enough, you could get into diamond and twist. But now, this is some things to look for. Again, I said there's no absolutes. I mean, you might be driving down the road texting someone or reaching on the floorboard and trying to get something and run into the back of someone and never hit your brakes or turn the wheel. So, but, a lot of times these are things that you can look for and consider, whenever you go to looking at a car and trying to develop a repair plan. And there's also different zones to look for. The first thing that you have is the direct damage. And this is very easy to see. I mean, it's the point of impact. That's the main thing that was hit. So the direct damage is the point of impact. But then you have indirect damage, and this is caused by the direct damage. And it's caused, it can be a number of things. It can be buckling, done in other panels from the damage from the force. It could be busted spot welds that you can find in additional panels, seam sealer that is cracked. I mean, it's not necessarily real easy to see. Indirect damage or secondary damage, you got to really look for that sometimes, and it can be travel throughout the car, because remember, the front and rear absorb, and it transfers around the passenger compartments. So the damage can really travel pretty far on unibody cars. And then you got to think of the mechanical components, and just like the Newton's law, the what's in motion tends to stay in motion. Well, if you think of a motor bolted onto a frame, if it wasn't bolted in, and you hit something, what's going to happen? Well, that frame's going to want, or that motor is going to want to continue going forward. So you may have to look at some of the damage going the opposite direction. So where the motor's bolted on, you may have to look for some of the damage going forward. Also, the same thing with the passenger compartment. The people inside the car, same thing. They're going to have damage going forward, even if they hit something going forward, and most of the damage is going, back. still, they're going to go forward. They're going to hit their knees on the interior parts of the car. The seat belts, they're going to be maybe some damage in there to look for. If there was things inside of the car that went flying around, that's things that you need to look for as well. And then the last zone is, like your trim and exterior components. There could be damage, like if you have some big mirrors on, you hit something real hard, that just the inertia of that, just the the force of it still wanting to go forward could cause some damage as well. If you had a toolbox in the trunk, that could cause some damage inside of there. So there's really more things to look for than the point of impact, that number one. If you just look at the direct damage, you're going to be missing quite a bit. So again, I don't want to get too in depth at this point, but just some of the things to kind of think about, as you start, you know, thinking about, developing a repair plan. So some repair considerations. If you're going to do a repair or replace it, there's some different things to think about that as well. First, can it be repaired? I mean, there are some uh, parts it just can't be repaired. It doesn't really matter if it was given to you for free. If it can't be repaired, you're going to have to replace the part. There's also the bend versus kink rule. If it's bent a little bit, you can repair it. And if it's kinked, if it's got a real sharp bend, and may even have cracks and tears in it, that's when you probably want to you're going to want to go ahead and replace. But still, that rule falls under the first one. If it can't be replaced, of course it's going to have to be repaired. Now the cost, is it going to be cheaper to repair it or replace it? For example, is that part, if it's $100 part and it's going to take you 4 hours to replace it or to repair it, which would be the better option? Well, of course, replace it's going to be better, even though it could be repaired. Because if you're at $50 an hour, that's $200 to repair it versus $100 for the parts. So that the cost is some things that you kind of want to look at as well. And also recommendations. There are some parts that don't, the manufacturer wants you to replace only, like we talked about. The ultra high strength steel and the boron. Those are, you cannot repair those. Those will replace only. Uh, some uh, some of your parts, the manufacturer only wants you to do a full replacement, and that means replacing everything at the factory seams. But a lot of times you can get by with sectioning. For example, a quarter panel, rather than going all the way up to the factory seam, you can section it in a smaller area, like up by your back glass, and section it, without getting into the roof panel. So those are some different repair considerations. And again, this, until we get deeper into it, this is kind of an overview, just to kind of some things to think about and consider. So in this video, we talked about absorbing energy, how cars are designed to do that. It creates a lot of damage to the car, but keeps the passengers safe, because the front and rear, it absorbs the energy and transfers around the passenger compartment, keeping the passengers safe. You have the different sides, the right and left, and the sections, the front section, the center, and rear. And the nomenclature, some of the parts of the car, the names of the parts, it's important to know that. The types of the frames, we have a body over frame, and that's where the body is bolted to the frame, two pieces. And then we've got the unibody, which is all welded together one piece. And then we've got the space frame, which is also welded together as one piece, but it has its full strength and integrity, without any of the panels helping strengthen it. We got the different types of metals. Mild steel is just regular steel, very easy to repair. We've got high strength steel, which is more heat sensitive, but it is repairable. And then we have a ultra high strength steel and boron, which is replace only. And those ultra high strength steels and borons are used mostly around the passenger compartment, to keep the passengers safe, transfer that damage or that energy around the passengers. And then we have attachment methods. Basically we have weld. We've got spot welds and laser welds that are done at the factory, different types of welds. We have mechanical, nuts, bolts, rivets. We have a lot of adhesives that's being used today. uh, repair cautions. Like borons in the ultra high strength steel, you can't heat it and you can't repair it. Um, and the types of frame damage, we have the sag and the side sway and the mash and the diamond and twist. And usually if you have the diamond and twist in your unibody, it's a good chance it's going to be a total. And we have the damage sequence, usually a lot of things that happen, but not necessarily. But chances are, more times than not, you're going to have the, hit the brake and cause sag, and turn the steering wheel a little bit and cause side sway, and then mash. And that's some things to look for whenever you go to repairing the damage, so that you can reverse that. And then we talked about some of the measurements and repair considerations. The control points that the factory uses to put the car together, and the reference points that we use to reference areas to measure from. And that can be control points, nuts, bolts, anything that they specify as a reference points. And the repair considerations. Can it be repaired? Is it kink? The kink versus bend rule. Is it cost effective? Those are some of the repair considerations. And again, this is just a real quick overview of vehicle construction, and we'll get more into depth in each one of those as we talk about more about the especially in frame damage. This is where this really is crucial to understand. But not to confuse you, just to kind of go over that real quick, so you have a kind of a the basics, the concept of vehicle design. And that wraps this up. And thanks for watching. Talk to you soon.